So let's generate our PE files, exe and DLLs. First, what we need is a source code. So let's go to our course materials, RTO, folder number 1, generate PE and implant. And let's open our source code in Notepad++. So as I told you before, you need a main function if you are implementing exe source code. So the main function is being called by the loader when the initialization of the process is finished, and this is our standard entry point for our code. And in this simple example, we will be printing a simple message on screen, followed by the system waiting us to hit any key. To compile it, we will be using a command line compiler, and I have implemented a batch file. And actually, this is a standard for the throughout the course, that any compilation you need, it will be done by the batch, so you don't have to worry about any settings for the command line compiler. It's all already prepared for you. So in this case, we will be taking our implant C++ source code, and a compiler will generate a program called implant.exe as a console program, and which is running as a 64-bit program. Okay, so we can close that, and let's run our compiler. So we open up a command line prompt. We go to Z drive to our RTO01 generate PE and implant, and we run compile. And if all goes well, we should have implant.exe. So if we run it, here's our message. And the process is actually running. So we can investigate how this process looks like in memory. And to do that, we will be using Process Hacker, which is really interesting tool, and really interesting in a sense that it's really cool because it contains a lot of fancy functionality, and it's much more complicated and much more sophisticated than like a standard task manager available in every Windows. So let's scroll down and find our process, which is implant.exe, and double click on it. And in this window and in the following tabs, you can find many information about the process. So for example, image file name is, the full path is shown here. It's 64-bit program, working directory is here, etc. The more informations, parent process with a PID. Let's go to modules. So modules tab contains all the DLLs loaded in memory of the process. So you can see it uses 3 DLLs, kernel 32, kernel base, and anti-DLL. These are pretty much standard DLLs used by almost every process. And if you go to memory tab, you can see actually what is the process layout in memory. Okay, so for example, you can see that at this address there is a section, read-only section, loaded from implant. There is another segment or memory region which is read-only and executable. So it means that it contains a executable code of our implant. And actually, if you double click on it, you can actually see all the code in memory. All right. So, and then you can also investigate the same layout of the following DLLs used by this process. Okay, so we can close it now. Let's exit it by hitting an enter, and let's go to and generate a DLL. Okay, so we go to implant.dll implant.dll folder, and there is a compile and a source code as well. So we go to, and let's see the source code for a DLL. So as you can see, the source code is a little bit different. So there is no main function, and we have a DLL main function instead. And maybe if you remember from the previous section, I told you that a DLL main function is a standard entry point for DLLs. Now, this function can be called in different situations. So for example, when the loader loads a DLL into a process, it will call DLL main, okay? If the system will unload the DLL from the process, it will also call DLL main function. The same thing goes with threads running in. So you create a new thread, or the thread being exiting in the process and resulting in the DLL being loaded or unloaded. In all these cases, DLL main will be called, okay? And this simple switch allows you to implement a different behavior on a specific event. So for example, if the DLL is being loaded for the process, the case will be DLL process attach, and it can be followed by specific, what to do in this situation, and it's up to developer, to implement that. If the developer wants to do something else when the DLL is unloaded from the process, then you can implement it here, okay? So it's really interesting. In our simple case, we will be using the same, like, very simple implementation. So basically, in every case, the DLL main will just return true. That's a default behavior. We also implement another function which is called runMe, and this function is being exported as an external function. So it can be called by the process, and it will pop up a simple message box on screen with the following message: RT operator, here I come. So to compile that, we will also need a compile batch, which is also here, and as you can see, it uses different switches, but again, you don't have to worry about it because it's already there. So we can run compile, and if all goes well, we should have a DLL, which is here, okay? Now, we can actually see what functions are being exported by the DLL. For that, we will be using dumpbin, and we need exports and a name and the actually full path, a path to our DLL. So in our case, it's just this one. And as you can see, implant.dll exports one function, which is runMe. And to run that, or to call runMe, we need a sort of surrogate process. So as I told you before, DLLs cannot live independently in memory. They have to be loaded in some process. Okay. In Windows, there is a program called run-dll, which allows you to do that. So you can load any DLL and call any function exported in that DLL. So in our case, it will be implant DLL and then runMe. And if we hit enter, we can see that the message pop-up is here. And if we go to process hacker, you can see the process run-dll32 is running. And again, more information. So from that, in modules tab, you can see there is an implant DLL. Okay, it's running. If you double click on it, you can even see here's the path to the DLL. Okay, and if you go to exports, you can see the exported function. And in memory, it can also see where this where this DLL has been loaded. Okay, so that's it. If we click OK, you will see that the process is gone. Okay, so yeah, this is how you can generate both exe and DLL files.